Best rice farming practices strategy number 1, the SRI revolution. That is understanding why conventional methods limit your success. Let's see the hidden problems with conventional rice farming. Before understanding why SRI and sustainable practices work so remarkably well, you must understand why conventional rice farming practices methods you have perhaps used your entire life actually suppress yields, increase costs, and make rice farming unnecessarily difficult and unprofitable. Conventional rice cultivation typically involves several practices that seem logical and have been used for generations but actually work against rice plant's natural biology. Transplanting seedlings that are between 25 to 35 days old seems sensible to ensure they are strong enough to survive. Transplanting multiple seedlings together in clumps of 3 to 5 plants seems like insurance against losses. Maintaining continuous standing water flooding fields through most of the growing season seems necessary since rice is a water crop. Applying heavy nitrogen fertilizer doses, trying to boost yields, and tolerating or reactively treating pests and disease outbreaks as they occur. These conventional practices feel comfortable because they are familiar and widely practiced, but each systematically suppresses your rice plant's yield potential while increasing your costs. The scientific research explaining why conventional methods underperform is compelling, and understanding it transforms how you think about rice cultivation. First, all transplanted seeds of between 25 to 35 days develop root systems adapted to nursery conditions that suffer severe transplant shock when moved to main fields, often losing between 50 to 70% of their roots during transplanting, requiring 2 to 3 weeks to recover before resuming growth. You are essentially knocking your plant's backward development. Second, transplanting multiple seeds in clumps creates intense competition, where individual plants fight each other for sunlight, nutrient, and space, resulting in weaker stems, fewer production tillers, and smaller panicles. You are intentionally overcrowding plants, then wondering why they don't produce well. Third, continuous flooding creates anaerobic, that is oxygen-deprived soil conditions that severely limit beneficial aerobic soil microorganisms. Restrict root growth to shallow depths because roots need oxygen. Reduce nutrient uptake efficiency. Increase methane emission, which contributes to greenhouse gases and creates perfect conditions for many disease organisms and pests, while simultaneously wasting enormous quantities of water through seepage and evaporation. Fourth, heavy fertilizer applications in anaerobic flooded conditions lead to significant nitrogen losses through volatilization, denitrification, and leaching. You are literally watching between 40 to 60% of expensive fertilizer disappear without benefiting your crop. The cumulative effect of these practices is rice plants that never reach their genetic potential. producing only 3 to 4 tons per hectare. When they are generally capable of producing between 6 to 8 tons or even more. Let's look at the revolutionary principles of SRI, working with rice plant biology. The system of rice intensification represents a fundamental different approach based on understanding and optimizing rice plant psychology, creating conditions allowing plants to express their full genetic potential rather than merely surviving suboptimal conditions. The core SRI principles that drive its remarkable success include transplanting very young seedlings of between 8 to 12 days old with minimal root disturbance when plants are still in their early vegetative stage, highly adaptable to new environments, capable of rapidly establishing extensive root systems in main fields without traumatic shock. You are working with plant development rather than against it. Second, transplanting single seedlings with wide spacing of between 25 by 25 centimeters or 10 by 10 inches in square patterns, eliminating competition between plants, allowing each plant to develop its full potential with adequate space for root expansion, light interception, and tiller development. Instead of many weak plants competing, you have fewer strong plants, each producing 30% to 50% more grain. Third, maintaining moist but not continuously flooded soil or soil conditions using alternate wetting and drying, that is AWD, or intermittent irrigation that provides adequate moisture while maintaining soil aeration, encouraging deep root development, enhancing beneficial aerobic soil biology, improving nutrient availability and uptake efficiency, reducing water requirements by between 25 to 50%, and suppressing many anaerobic pests and diseases. Fourth, actively aerating soil through mechanical weeding, that is 2 to 3 times during early growth, simultaneously controlling weeds while incorporating oxygen into soil, stimulating root growth and tillering, creating favorable conditions for beneficial soil organisms, and limiting competitions from weeds. The physiological responses of rice plants to these improved conditions are dramatic and well documented through thousands of scientific studies. Young transplanted seedlings develop root systems between 30 to 100% larger and deeper than conventionally transplanted seedlings, accessing water and nutrients from greater soil volumes and providing better drought resistance and nutrient uptake capacity. Single plants with adequate spacing develop between 40 to 80 productive tillers per plant compared to between 15 to 25 tillers typical in conventional clam transplanting, with each tiller producing a grain-bearing panicle. Alternating wetting and drying stimulates root growth. That is, roots grow deeper, seeking moisture during drying period. Increases tillering. Plants respond to periodic mild stress by producing more tillers. Improves nutrient uptake. Aerobic conditions enhance microbial activities and nutrient availability, and strengthen stems, making plants more resistant to logging. Mechanical weeding not only eliminates competition, but the physical soil disturbance stimulates tillering and root growth, similar to how cultivating vegetable gardens improve plants' vigor. The result is rice plants that look dramatically different from conventional plants. Thicker stems, darker green leaves, indicating better nitrogen uptake. Between 2 to 3 times more tillers, larger panicles with more grains per panicle, and often taller, robust plants that nevertheless resist logging because of strong root systems and thick stems. Best rice farming practices strategy number 2, that is nursery management and transplanting. This is the foundation of SRI success.